So hello guys, assalamu alaikum. My name is Malcolm. Today we are going to discuss about the solid state of matter, and we have discussed the liquid and gaseous state, and we have done the introduction as well. So now we are going to start the new chapter, which is solid state of matter. So what do we know about the solid state? Like, only solid. So first thing that you have to know about the solid state is that the inner particles of the solid is arranged orderly, okay, arranged orderly and tightly packed to each other because of the intermolecular forces. Which kind of forces we'll discuss in the further videos, but currently now we are discussing only the introduction regarding the solid. As we know that in liquid and gas, the the particles cannot make any shape of color, like kind of container, okay. They cannot make shape of any like container, but solid can because of the tightly packed particle. If you talk about that, how much particle move from here to there, from one point to another, so they do not move. They just move their what we say in the mean position, and they just vibrate like this. If you have seen the structure, like, they just vibrate. But in liquid and gas, they flow and can go anywhere. And as you can see that, as you can say, the gaseous state in the container, the molecules of the gas particles collide with the container, okay, the wall of the container. So yeah, that's the phenomena of that. But if we talk about some properties of the solids, so first property that we got is compressive, like compress. If we do compress solid, so it is like uncompressible because of the molecules. As I said, that they are arrangedly like orderly arranged and tightly packed to each other, so they cannot like compress. If we talk about the kinetic energy, so I have already told about that. They just vibrate in the mean position. They do not move, or they do not, like what we say, collide with any kind of what we say container. If you talk about the volume, so volume is higher, like very higher than these states, like liquid and gas. Liquid and gas has less volume compared to the solid. So yeah, that's the another point. The third point that we are going to discuss is that if you talk about the melting, so it takes higher melting point to be melt, because of the strong internal forces between the molecules. So it takes a lot of temperature to what we say, to reduce the intermolecular forces to break down into pieces, or what we say. So the second thing is that sublimation. What does it mean? Like, if you know that, first of all, we have gas, okay. It converts to liquid, then it converts to solid. Same as here, if you take it reverse, first solid, then liquid, then gas. The perfect example of this is ice. Firstly, it convert from solid to, sorry, liquid to solid, then what we say, liquid to solid, then solid to gas. But in sublimation process, the kind of solid directly converts from the solid to gaseous state. This thing we'll discuss in the further videos, but currently I'm discussing about the properties of the solid. And if we talk about the further what we say types of solids, so we will got the amorphous amorphous state, and what we say, crystalline state. Okay. So what are these? First of all, you have to understand the comparison between them. If you talk about the crystalline, so crystallines means the orderly paired particles of the solid, and due to the strong internal forces, they cannot move to from one point to another point. But in the amorphous, it doesn't happen like that. If you look at the structure of the amorphous state, so you will get the molecules like this. Some will be like this, some will be like this, some will be like this, but they will have the structure. And the main point to be noted is that they deals with the 3D dimensional, like three dimensional, x, y, and z. Okay, if you know about the axis, so you will know it better. If you talk about the axis, so the crystalline state lie on the axis like this. As I said, orderly paired, okay, so they lie on the axis like this, okay, like this. Okay, I'm not drawing completely, but you will get the idea by this line. And but in the amorphous state, they what we say, they arrange like that. Some will be here, some will be here, some will be here, and other will be here, but very less amount of particles will be orderly like this, but some of them will be like whatever. If you talk about the melting point, if you talk about the melting point, so in the melting point, there's a very what we say a unique thing about the crystalline and amorphous is that you can melt crystalline state in one temperature. For example, if you take 100 degrees celsius, sorry, if you take 100 degrees celsius, it will directly convert to the solid to liquid. Okay, there isn't anything unique. Okay, but if you take amorphous, you will take, firstly you will what we say, you will take 30 degrees celsius, it will start melting and converting to liquid. Okay, but not completely. If you increase the temperature to 80, then it will completely, what we say, then it will be completely convert to solid to liquid. Now why is this happen, why do we have to increase the temperature of that? The reason behind that is that in the amorphous state, as I told you, that they are not orderly paired or arranged. Okay, because of that, some will be paired, some will be strong, some will be have the strong intermolecular forces, but some will have weak forces. So because of that, in the 30 degrees celsius, only weak forces will be like breakdown. Then if you increase the temperature, then will be the strong, what we say, strong intermolecular forces will be breakdown. So yeah, that's the reason. But in this case, every particle is arranged in order pair and has the same amount of intermolecular forces. So that's the reason in one temperature you can convert it directly from solid to liquid. So these were the properties and the introduction of the solid, but in the further videos we'll discuss about the melting point more and the rest of the properties. But for now, this is the thing. Thank you so much.